Good afternoon, everybody, and welcome to today's Embarcadero webinar, Advanced Business, Scientific, and Engineering Application Development. My name is Kevin Askew. I'm Director of Sales here at TechExtend, and along with Embarcadero, we'd like to welcome you this afternoon. Today's agenda will include a little bit about who we are here at TechExtend, followed by today's webinar hosted by David Ives, Vice President of Developer Relations and Chief Evangelist at Embarcadero. We will then have a question and answers period and then the summary. TechExtend, formerly known as Programmer's Paradise, is a leading value-added reseller of developer and infrastructure tools. We can be found on the web at www.techextend.com. We are an Embarcadero webinar reseller, and under our ALM worldview, it includes RAD Studio and JBuilder, and under our database worldview, DB Artisan and ER Studio. We also offer team development services under assessment, deployment, and migration. Also under our ALM worldview, we provide industry-leading tools for your end-to-end development needs, including defining, designing, developing, testing, deploying, and managing. So now, without any further ado, I will now turn things over to David I for today's webinar. David?
Great, thank you, and welcome everyone. We're here in our Scotts Valley studio, and let me just make sure I'm on my my slides. And here we are. So again, it's great to have all of you here, and with me is Anders Olsen on our DevRel team. Hey, Anders.
Hello.
And Anders is working on several of the demos that we're going to show you today, and he also has written articles on our developer network and articles in his blog that takes you through how he built these applications. So we'll spend a little time with Anders in those as well. I just wanted to go quickly through a reminder of what's included in RAD Studio XZ2. It includes our Delphi, C++ builder, RAD PHP, and Embarcadero Prism products. So all of that in RAD Studio, but then each of the products is available individually as well. With RAD Studio XZ2, you get native code compilers to build native applications that look and work beautifully on Windows, on Mac, in web architectures, and on mobile devices. You can do full database access. We have native code compilers for Delphi and C++ that run on 32-bit Windows, 64-bit Windows, and can compile for Macintosh OS X as well. And with our Delphi language, you can also leverage the free Pascal compiler to build applications for iOS, for your iPad, iPhone, and iPod Touch-based devices. And with our PHP product, you can build full PHP server-side web applications, client-side applications using JavaScript and Ajax. And you can also use jQuery Mobile to build mobile client applications with PHP for Android and iOS. So many ways to build mobile applications with RAD Studio XZ2. When we released XZ2, we also introduced a next-generation business application platform we call FireMonkey. And we're going to spend all of our time today in the demos showing you all the different things you can do to build high-definition and 3D business applications, scientific and engineering applications using FireMonkey, with full connectivity to data, with full user interface controls, with support for 3D models, for data visualization, and so on. And you'll see all of that again in the demonstrations today. If you have data out there somewhere, whether it's on a database, whether it's local, whether it's in a cloud, whether it's on a remote database server, we have all the components to connect you in all of the 4 development products that are inside of RAD Studio XZ2. So if you've got data in S3 at Amazon, or you've got data in an Oracle database, a MySQL database, or if you have some other database, we can always connect to it through ODBC as well. And again, as I mentioned before, we have, I think, 9 or 10 different ways that you can build mobile applications and hook mobile devices into your existing infrastructure. We have native connectivity for iOS, Android, BlackBerry, and Windows Phone 7 to build client-side applications in the languages of those platforms to connect to data snap servers that you would build in our Delphi and C++ builder products that would run on Windows or Windows servers. And again, you can also build Delphi applications with FireMonkey that run on iOS as well. And then with our mobile-optimized PHP, you can build Android and iOS applications for iPhones, iPad, iPod Touch, and for Android tablets and phones as well. So a quick overview of FireMonkey, and we're going to spend the rest of our time in the demos for this. With FireMonkey, you only have to think about one thing. You think about the language you're going to use, Delphi or C++, and then you have to only think about one tool set, the compilers and our IDE, one business application platform, FireMonkey, one programming model. You program to FireMonkey instead of having to learn how to program to do 2D or 3D graphics with DirectX on Windows and then OpenGL or Core Graphics on Apple devices or something else. You only have to program one way, using the language that you want to use. And then you just recompile it using our compilers and our runtime libraries for the platforms that you want to deploy your applications to. So you can sit inside the IDE, build your application, and deploy it where we have compilers for those. And we'll be adding more and more compilers in the future and more platforms that we target as well. Now, we've been stuck with user interfaces like Windows, and they look kind of old and tired for a long time. But with these smart devices and tablets and phones, we're seeing now the rich experience for users. Swiping, page turning, smooth scrolling, all of these kinds of things that have become the norm, except maybe if you're using some older tools building Windows-only applications, or you might have to figure out how to program for each of the devices. And again, FireMonkey takes care of that for you. FireMonkey is not a rich internet application system like Flash. It is not a rich web system like Silverlight. It is not Java or managed code. It's not a game engine. It doesn't do anything right now with HTML5 and CSS3. It's all about building native application, high performance, native compiled code that will run on the Intel processors today and the ARM chip on iOS today as well in XE2. So you get the full richness of 2D, 3D, of the user experience that you want, of beautiful looking styles, making it look like the operating system and devices that it's running on, like all the other applications users use. All that's built into FireMonkey. And at the same time, it uses the power of the CPU and the power of the GPU to give you high-speed performance. So if you want to build visually stunning applications that are highly interactive, if you want to have high-speed compilation and algorithms for your own code, your own business logic, and if you need to connect to all sorts of different things, web services, Java infrastructures, database servers, cloud servers, and so on, all of that is available from your FireMonkey applications. And again, as I mentioned, it's native code, takes advantage of the CPU and the GPU for your application across the platforms that we support in XE2 today. So you compile it, test it on Windows in our IDE, then you cross-compile it, test it, debug it on a Windows target from our Windows IDE, and then you could also compile and target iOS. In that case, you'll debug from Apple's Xcode environment, at least currently in XE2. And the way FireMonkey works is you program to FireMonkey. You program to FireMonkey's coordinate system, FireMonkey's component system, FireMonkey's infrastructure, and then it does the work to get you to the low-level graphics chip on the platform you're running on. So we use DirectX for Windows, Direct2D and Direct3D. We use OpenGL on Macintosh, and we use OpenGL ES on the embedded devices of smartphones, tablets, and so on. And again, you use the interfaces and the components and the architecture of FireMonkey, and the FireMonkey runtime and implementation does the right thing for you. But you still have full access to the underlying operating system, full access to other things that you might need to do with the target platform. This is just a high-level diagram of some of the components. We have shapes, we have all the usual user interface controls of text controls and toolbars and scroll bars and panels and tab notebooks and all of these kinds of things. Now again, if you want to do 3D programming, different 3D systems have different coordinates, different orientation. Direct 3D has different graphics orientation and X, Y, and Z than OpenGL, for example. So what we did in FireMonkey is we have a single, we call it the right-handed orientation. So this little hand diagram is telling you that what happens as far as the coordinate systems are concerned. X grows to the right, positive X to the right, minus X to the left, from 0, 0 at the center, positive Y going up, negative Y going down, positive Z going into the screen, negative Z coming out of the screen. So one system, and then FireMonkey does the transformations under the covers for you for whatever target system you have, whether it's DirectX, OpenGL, OpenGLES. It just works. You'll see it in action today. This is a little UML diagram of some of the FireMonkey 3D types. There are many more, but you'll see some of these in action today. Rectangle 3Ds, ellipse 3D, text 3D, path 3Ds, plane, cylinder, spheres, cones, and ultimately there's a mesh as a 3D object, and you can create your own custom mesh, and we also hook that into doing 3D modeling or support for 3D models. And today what we do, we have a component that supports a Collada DAE file format, OBJ format, and AutoCAD Scene Editor ASE format. And we also have a demo example that's available in our repository and with our product that allows you to import 3DS or 3D Studio models as well. And so you'll see some of that today. So very simple architecture, but extensible architecture as well. If you need something else, inherit from one of our components, one of our interfaces, and add functionality. Of course, we'll be adding more functionality over time as well. If you've got data that you want to bind to the properties or values or interfaces of components, we have a LiveBindings system where you can specify expressions. You can bind data coming from databases, bind data coming from your own objects, or from some kind of enumeration or some list, and you can bind that to a grid, to an edit box, or whatever. We also have support through the mesh and through the Model 3D for doing data visualization. So you'll see some of that in action here in a very quick moment. Again, the whole idea there is new ways of visualizing data and new ways of being able to build data-aware applications in your everyday business work. Maybe you're coming from a science, engineering, or mathematics background, and you want to be able to use a programming system to do some automation in Delphi or C++ and have these great, rich kind of experiences. FireMonkey allows you to do that. We also have with FireMonkey, as I mentioned, we can connect to other infrastructure pieces that you have. So maybe you've got a remote database or a cloud storage system. Maybe you've got some web services built in SOAP. Maybe you've got some REST servers. Maybe you want to integrate with some internet infrastructure pieces. Again, FireMonkey has full support for connectivity to all the different back-end systems that you might want to connect to with SOAP, REST, databases, cloud storage on Amazon S3, and Microsoft Azure blobs, tables, and message queues. Again, I mentioned we have this Data Snap Server technology. We have lots of information on our website, lots of videos about Data Snap Server, building these Data Snap Servers. They're Windows native 32 and 64-bit applications that can serve up REST interfaces so that you can make nice calls and just make function calls to a remote object and have it return data sets to you. Again, we also can build FireMonkey iOS clients that can talk to Data Snap servers. And if you've got something in your infrastructure, FireMonkey can usually connect to it. If it can export a SOAP interface or a REST interface or some remote procedure call of some kind, we can figure out the coding, and we have examples to help you connect to those infrastructures. So with that, I'm going to switch to my desktop and then also hand the ball over to Anders, who's sitting next to me here. We're going to go through some different examples and the source code for some demonstrations built in FireMonkey. And at the end, I've got a product that's for sale called Multi-Track Studio, which is a Delphi VCL application that runs on Windows, has been recompiled for 64-bit Windows and has been moved over to Macintosh by using FireMonkey and all the rest of the logic of mixing of audio. And it's a multi-track audio mixing software out of Germany. So we'll take a look at that as well. So let me share my desktop. And I'm going to switch over to my IDE. And let's just start with a simple example. This is a Delphi example. There was a 3D graphics application called CoverFlow that has been around for a while. And you'll see that used in lots of different, that model used in lots of different things. If you go to iTunes, for example, and you're browsing through albums of artists, or if you go to SketchUp 3D Warehouse from Google, you'll see kind of this flipping metaphor of flipping through pages or flipping through albums or flipping through movie posters or books and so on. And so we've done that as well. Let me just run this real quick, and let's start it running on the Windows platform. And this is the Delphi version, and I'll also show that we have a C++ version as well. So it asks you to go find some pictures, and then as you move, either with the mouse or with your keyboard, you'll see what's happening is it's taking an image. It has a list of images, and it's taking that image and it's moving it. So it's moving it forward. So watch the koala bear. It's moving it forward over to the right, pushing it to the back in the Z positive axis, and then turning it at a 70-degree angle, and then bringing the next picture up to the front. So now it goes to the left because it knows it's on the left-hand side, and then it pushes it at a 70-degree angle. And we can use the track bar down here as well to move through these. If we want to run this same application on Macintosh, we just select the target platform, Macintosh OS X, and we'll say compile and run or debug. And then it will compile and deploy it. So if I go back over to my Macintosh desktop, I've got the same application. Let's give it some pictures. So here's some pictures again, and the same interface. You know, click on it with the mouse, skip pictures, use the arrow keys, use the track bar, and so on. All right. So same application written in Delphi and FireMonkey using 3D graphics. Also notice it's using other effects as well, and we'll take a look at those. This is a reflection effect. That's just another component in FireMonkey that you can connect to an image component and do image processing. So maybe this reflection could be the grayscale version of the picture, it could be sepia color. There's lots of different image effects. And all the effects are being done by the graphics coprocessor. So let me go back and let's take a look at the source code. So first, it's just a form, and on that form it has a viewport 3D. So a form in FireMonkey can be either an HD form, a 2D form, like traditional Windows, or it could be a 3D form that you would place 3D objects in. In this case, this was built with a 2D form, and then it has a viewport 3D and a layout 3D component to lay out all the images that are going to appear inside of the viewport. And then there's that track bar that we mentioned. There's a little animator indicator, that little spinning thing that happens, and there's a button for loading files. And then as we scroll and move the mouse wheel and things of that kind, other things can happen. This is where you can specify the rotation angle of the pictures that are stuck behind. Right now it's set to 70 degrees. And if you're doing an animation, then it has a duration of a half a second, but you can tailor how fast or slow that flow of the image to the background or bringing it to the foreground happens. In the code, it's just running through and it's opening up all the files. So we set a dialog filter for the open dialog box. And this open dialog is a FireMonkey dialog. And then it's going to create the layer 3D. The parent is going to be the form. And then we'll just set the height and width of how big we want the flow to be inside of the parent window. And then we'll set the X, Y, and the angle for the pictures, how they're going to fit. We'll create the layout, and then we'll start loading the pictures in. So we'll get the image size, and we'll set the image height and width for each of the elements that are going to appear in that flow. And then finally, here's the reflection effect. So we'll create a reflection effect, and we'll put that effect, make the image be associated with the parent. And you can set the transparency as well. So we use the term opacity, but if you want your picture to be sort of transparent in the background and then completely visible when it comes to the front, you can set the opacity property. And then here's this animate. So we have these animators, and what animators do in FireMonkey is they animate a property and a property type. So in most of the coordinates, in the coordinate system, everything is floating point. So we're going to, or in this case, we're going to change the opacity. So you set the property that you want to set, you set its value and the duration of the value. And then when it's done, set the track bar to be the number of children or number of images that were found. And then when we start it, it just starts and it adds the folder and everything gets displayed and we can start doing the interfaces. Again, if we want to use the mouse wheel to move, it just changes the track bar value, which will cause the pictures to move as we roll the mouse wheel, if you have a mouse wheel, or you could be using a touchpad or arrow keys and so on. And then down below here, it just does the animation of the different pictures. So when it has to move the picture to the back, either to the right or to the left, it does it by animating the X and Y coordinates of the image. And it does it over a period of time, duration. And again, it's just setting the value of the rotation angle of Y or X on either side of the picture or cover, in the sense of like an album cover. And then we tell it to stop its animation when it's done. And here, just, you know, if we're using the track bar and it's got to change, the change event, then we'll just take the value and bring that picture to the front. Or if we do a mouse down on either side of a different picture, then again, we'll just set the track bar value and cause that picture to be the one that comes to the front. Now, we also have this same application in C++. So let's go to the C++ version. And again, this runs on Windows and on Macintosh, so we can have the platform either be 32-bit Windows or Macintosh OS X, and we can run the application. And select, again, pictures. So here's our flower, the samples that come with Windows. There's that animator, right, that comes up. And again, here's the beautiful koala and the penguins and so on. Right? And again, with the same reflection effect. So FireMonkey is available for Delphi and for C++ Builder on Windows and on Macintosh and on iOS. Now, same in this case, the code underneath is the same flow. It's just written in C++, right? So if you're a C++ developer and you need to build graphically rich applications, you can do that as well in C++. Now let me bring up another example that uses the same logic of the cover flow, or what we call fire flow for FireMonkey. But in this case, it's going to display database information. So instead of being images, it's going to create different database forms that you can edit the data and display different aspects of your business application. And the way that works is that it's got multiple forms. So for example, here's a summary form that has, this is TeeChart Lite from Schema software, which is included in Delphi and C++ Builder and XE2. And we can do binding of data from a data set to bind, in this case, to a 3D bar chart. And we can actually then rotate the 3D bar chart and look around, hover, and fly around the data. We have a main form, and we've got a data form as well. So here's a data form that's going to have information about different species of fish, their size, their name, their length, a picture of them, and so on. Again, coming from a data set. We can actually edit the data. So all these are individual forms. And now in the main form, what happens is down below, it creates the layer just like we did in the FireFlow example. So here's a 3D layer. And then it's going to create, using the data set, for all the entries in a data set, it's going to create a form for each row in the data set and put those add those to the 3D layer. So again, we can use the same kind of system and user manipulation of images of beautiful koala bears and penguins. But in this case, bring that same richness to a business application, looking through rows of a database. Might be customer data, sales data. The chart might be a chart of business activity. So let me run this again. This one is a Delphi application, so 32-bit, 64-bit Windows and Macintosh. So let's run it on Windows, and again, you'll see how instead of maybe putting up a tab notebook of all of the information that is in your database and stepping through rows or bringing it in a grid, you can actually give it a graphic richness. So here now we've got the click on different species of fish. These are actually updatable forms, so we can go and we can save the data back and refresh it as well. And we can continue to step through rows of data. Here's a bitmap blob that's coming. Here's a text blob that's coming into a memo field and an image there. Again, I can use the arrow key, I can click, I can move the track bar. So think of this as these are customer and orders, for example, in your business application. And this kind of richness here, let's zoom it up as well so it looks even better. And some of those forms that you stick in the flow can be data. In this case, it's a 3D chart, and I can rotate by I'm holding down the left mouse button and zooming in and out, and we've got lighting effects. And what we're doing in this case is I'm not having to do anything other than I'm moving the camera. I'm moving the camera to look around, look down, look over the top. I mean, if I really go over, I'm going to see the back side, which there's nothing exciting on the back side there in this case. Maybe we didn't have a back and we want to look at the data from behind. There's also a 2D view, which is just a traditional 2D bar chart of data bound from the client data set, the lengths of all the different fish. And again, the 3D model coming back here. And looks like he's not updating the reflection, but that is done with a single statement as well. All right, so again, using a same graphically rich metaphor of moving through images, moving through rows of data, customer data, sales data in a database, 3D bar charts with TeeChart Lite built into the product, and then you can get the professional version if you want from Steema software as well. Now let me do a couple more, and then I'm going to turn it over to Anders for some more demos. So again, the key here is it's the same programming metaphor. In this case, I'm just creating multiple forms for different views of my database, and then I'm attaching each of those forms into this layer 3D list so that I can step through them using the same move to position if I change records and so on. All right, using the track bar at the bottom. Okay, let me go back down here. Another example, maybe you work in a world of chemistry or of manufacturing of chemicals. This is an example that takes a representation in a data structure of a caffeine molecule, and it uses a different user interface. It uses spheres and the bonding information between the different atoms inside of a molecule, and we can, and then it simply draws the line. So in FireMonkey, this is pretty straightforward. It's a T-sphere 3D object and a line object that goes from the center of each of the spheres. And again, I can zoom in and scale these, and I can rotate them and pan them and move them in a different world. And he's got, this was done by Pavel, he's just got some other, so you can see some 3D shapes that are included in FireMonkey as well. But for caffeine, he actually is taking the representation, which is in a format that I forget, and he's displaying them. So these are, Anders, these are what? These are rectangles? Is that it, the lines?
There should be cylinders.
Cylinders? Okay.
They look
Cylinder
like
object.
rectangles. So.
Yeah. Okay, one last one, I think, from me, and then Anders has some really cool demos as well. So this one is a data visualization. So what I have is I have a database. It's an interbase database. And what it has inside of it is it has information about the states of Brazil. There are 27 states, including the district, the federal district, which is like our District of Columbia. It's this area of Brasilia. And inside of there, I have a SQL query that's going to get me the state information. And then in another table inside the database, I also have census population data over time from 1872 to, I think the last census was done in 2010. And I'm going to display a map of the states of Brazil on Viewport 3D. And then I'm going to, and I have a camera that looks at it, so I can look at it. I have a light. Let's see, oh, maybe I took the light out. Okay, so then I have a layout 3D, and I have a path 3D. And what path 3D is it allows me to specify some path data that will draw the outline of each of the states. And so in code, I have an array of data about the state's abbreviation, its name, and instances of these tPath3D objects where I can load the path in for the shape of each state. And then I have an array of the years where there's census data, and then I have a color array for these alpha colors so that I can display a different color for each of the states. And down below, I open up the database, I do the states query to get the state data, and then I just set the abbreviation, the name, and I create the instance of a path3D object, and then I set its parent to be it's part of the layout, and then I go and I get the path data out of the SQL query. And then I specify where it goes on the X and Y on the screen for FireMonkey, and then I display its height and width, and ultimately I set its depth to 0 until I start putting population data to watch the population grow and watch the extruded path data grow out as well. And I set the ambient color and the fill mode for the material in the path. And I set the track bar, so I run through all the states inside the database. And then when it's time to populate the data, I do my population query based on the year that I'm on for a certain year. So I set the parameter of the population SQL query equal to the year name that I want, 1872, 1950, whatever it might be. Do the query, and all I have to do for the path to make it extrude its shape is I'll set the depth equal to the population value. Oops, sorry, let me, I dragged it instead of, let's see, there we go, okay. I set the depth of that path 3D equal to the population divided by a scale factor, because of course some states have millions of population, others have hundreds of thousands. So, and then finally I set the Z property so that to a negative of the state array's population, so that I can extrude the population out towards you, meaning the negative Z axis of the on the screen. And the way I do that is I've got an open source tool called Inkscape. How I got the outline of the states, let's bring that up. It should come up here in a moment. Here it is. So Inkscape, you can go to inkscape.org, and one of the things it can do is it can open SVG files. So let's go and find my SVG file, which is here in data visualization. Here it is. And Brazil, and the SVG file is here. So here's the map of Brazil that I got from the internet, and it has an outline drawing of each of the states. And the way to get the path data is out of Inkscape is to say edit XML editor, and inside of here you can find all the different paths. And so I took each of these data path data for each of the states, like there's Sao Paulo, and you can see them highlighted on the maps. I took the path data, I stored it into a text blob in my states table in my Brazil database. All right, so let's take a look at this in action. Let's run it. And when I open the states database, there's the starting set of states with the population for 1872. So here's the states, and then what I can do is I can move the track bar, and I can start watching the population grow over time. And you'll see very quickly that Sao Paulo state is growing the fastest. Now I've also got my mouse connected so I can use the mouse wheel to zoom in and out so that the Sao Paulo state population doesn't go off the screen. I can also grab, using the left mouse button, and grab and rotate around the image so I can look at it from different aspects. Maybe look straight down inside of, there's that federal district, so I could go and zoom in the federal district area, for example, and see that its population has stayed pretty small. And then I hooked in an animation and loop so we can just watch it grow over time as well. All right, so the outline of the maps came from an SVG file stored in my blob, text blob of my database for each state. Then I load that path data into the data of a TPath 3D component in FireMonkey. All right, with that, I'm going to turn it over to Anders, who has some demos to show you as well. Let me stop the animation here. And again, we'll make all of this source code available in on our websites, and we have a repository and source for it. So we'll make sure that that you can find it. So I'm going to pass the ball to Anders. And Anders, back to you. And then I'll come back, then it'll come back to me again just to finish up.
Okay, so you should see my screen now. So I wrote a couple of demos and I wrote a couple of articles. I'm going to discuss these here. So if you go to edn.embarcadero.com and click on Delphi, you'll be able to find these articles. The first one is visualizing mathematical functions by generating custom meshes. So we're going to talk about how we can create custom meshes and give them color information and things like that, so that you can get nice looking visualization here. So here's the final result for this particular function. It's the sine of a couple of arguments squared divided by the same argument. And if we take a look at how this is generated, how the wireframe is generated, so we see here that the wireframe, if we take off the texture, the wireframe consists of a whole bunch of triangles. And of course, the easiest way to get a triangle when you're looping over X and Y is to imagine that you have this red square, you cut it in half by the diagonal, and you end up with two triangles. So now we're going to generate those triangles by populating the vertex buffer and the index buffer that's part of the T-mesh structure. And then we generate a texture, a color map. We do that by simply creating a bitmap that we then tell the mesh that depending on the value of the function in a particular point, we're going to pick a color. So as you can tell here, we're going from this side of the spectrum at the low values and then going blue, green, and red at the top, right? And here's a couple of other functions in there. The other article is on visualizing wave interference. So as you can imagine, you take a couple of different functions, and as opposed to generating a static picture, you will actually see this thing looping over time. So let's take a look at the actual projects here. First, the math visualization. So this is a little updated. It's got a couple of different buttons on here, so we can pick a function. We can rotate it around, look at it from all the sides. We can also spin it around the x-axis. We can zoom in and out, see what's going on in the center of it. We can turn off the grids, stuff like that. Look at different functions here.
Looks like battery.
Yeah, this is my bat ray function, or if you turn it upside down, it's kind of a saddle. There's a different one. This one's kind of interesting. It's symmetrical on all four sides here. And a little arctangent tangent function here as well. So let's run this on Macintosh just for fun here. Should pop up on the Mac side momentarily. So here it is running as a Macintosh application. Same thing, we can rotate around, go around the x-axis, zoom in and out, turn on and off the grid lines. So if you look at how this is done in code, I have a generate mesh function that simply goes ahead, and the first thing it does is clear what's in there already, and then we set up the buffer lengths for the vertex buffer and the index buffer. So this is basically a way of building up the triangles. You can also, if you look at the T-mesh, it actually has a couple of string properties to take care of triangles, points, and texture. But when you're dealing with a lot of data, in this case we're dealing with tens of thousands of points. I think it's almost 60,000 points in this one. And when you're dealing with a lot of points, the string parsing gets very tedious. In fact, in this demo, it takes about 60 times longer to deal with the strings than it does to deal with the direct properties, the vertex buffer and the index buffer. And that will take a significant amount of processing power when we get into my wave visualization and you're actually visualizing stuff happening over time as opposed to building a static mesh. So in this case, we simply calculate for my two triangles or my square. I have 4 points around the square. I calculate the function values for each one. I assign the points, P0 through P3. I assign the texture coordinate and calculate the color index into that bitmap that I had. And finally, I map the triangle. So the first triangle consists of points 1, 2, and 3, and the second triangle consists of points 3, 0, and 1. So that makes up our square. And the rest of this is for the rotation and things like that. So let's take a look at the mesh as well. I'm sorry, the wave visualization. So here's my wave visualizer running on Windows. So I can turn on wave number 1, and you should see it fluctuating here. I can change the location of it, where it's actually So imagine you have a wave that's continuously spreading from this point. You've got some kind of point oscillating here.
Water drops or something.
Yeah, there you go. Continuous water drippage or whatever. You can change the amplitude.
Oh, your fan has gone on for the GPU, I think, as well.
Yeah, that's true. That happens. You can set the wavelength. All right. And you can set the velocity that it's spreading by. Of course, then for interference, you can turn on the second wave and see what happens, or in the third wave and the fourth wave. You can change the amplitudes and get kind of interesting effects in here. Again, we can spin this around and see what's going on from all different angles. So we can try to get a side view here. Okay, and in code, this is very similar to the other application. I've got a wave, a T wave is a record, whether it's enabled, or what the amplitude is, what the wavelength is, X and Y, where it's located as far, and the speed or velocity of movement. I set up 4 constant starting waves and just give them, the only difference is here they're located at the 4 different corners of your imaginary square when you start out. The wave function is very simple. It's got an amplitude multiplied by a sine. The sine internal is simply related to where's my X and Y. So what's the distance? This is the distance from the X and Y that I'm iterating over compared to where the actual point of origin is. And then I have my velocity, and the time factor comes into play here as well. So then when I generate the mesh, very, very similar to what I had before, I set up the lengths of the buffers. I set up a bitmap of colors. I calculate the values for each point for the 0, 1, 2, and 3, because I'm still creating triangles. Same as before, the points become, there's 4 different points that then get mapped to 2 different triangles, and here is the color information mapping. So then I can run this on the Macintosh as well. Go ahead and run that. Here's my visualizer on the Macintosh. Same thing, I can change the amplitudes, I can change the wavelength of something else, the velocity of something maybe, and my rotation logic isn't happening on it for whatever reason. It got disconnected, I guess. Oh, I was, that's right. Anyway, excuse me. Let's take a look at the an iPad version. So here I have a very simple version of the mesh on the iPad. So here you can see this is a 50 to 60,000 point mesh on the iPad. So you can see it's highly responsive here as well. I don't have the wave propagation or wave interference one happening on the iPad yet, but eventually I'll get there as well.
In this case, you're using the simulator versus the device. We'd have to set up a camera on the
device.
I
don't have the camera set up, and I wasn't sure that WebEx would be able to handle live video feed. But my final example here is going to be my quote-unquote solar system. So the idea here is that we have a, it's not really the solar system, obviously, because Mars isn't located here, Jupiter isn't located here, and the Earth is the only one that's in correct relative position possibly. But if you actually took into account the relative distances between the planets and all that kind of stuff, and the masses are massively different. I think Jupiter is 300.
And Anders and David, we just lost your connection. If everybody could just hang tight for a second, we'll get them back. Just hold tight for a minute. Sorry for the technical difficulties.
Can you hear me?
Sounds good, Anders. Thanks for coming back.
Okay.
Our phone system died.
Our phone system died in the building apparently, so now you're on my cell phone. So can you still see the screen?
Yeah.
Okay, I turned it on so that we actually see something happening. So, yeah, so the idea here is just to set up a fake Kepler system, if you will, a gravity system. And we got 3 different planets, and there's a moon rotating around the Earth here. We can start and stop the simulation. We can look at the sun from the Earth and start the simulation. We can stand on the sun and watch the Earth. So now you see the Earth and the moon spinning around it, coming closer.
In that case, you're telling the camera to point at a target, right?
Yes. In this case, I'm telling the camera to continuously watch a target. That's correct.
Okay.
So let's run that on the Macintosh as well. So here we have the same thing running on the Macintosh. Standing on the Earth, watching the sun. Standing on the sun, watching the Earth, or back out to my outer space location here. I can spin it around, see that it's actually running flat on a line or on a plane, if you will. All right, let's stop that, and I think we go back to, actually, you know what? I wanted to show one more thing, which is the difference between HD and 3D. So David's waving over here, but I think it's important here. If we look at just the CPU usage, if you create an HD application, I'll bring it up a little bit. Okay. We can see here when we start the simulation that it's using a lot of CPU, especially if we go full screen. It does use a significant amount of CPU here because this is a inherently 2-dimensional application with a viewport 3D on it, and that uses the CPU as opposed to the GPU. If you want to take full advantage of the GPU, your application needs to be a 3D form, or your form needs to be a T-form 3D. So here, if we start the application and we run around, we'll see that we don't have any CPU usage hardly at all. All of it is generated and rendered on the GPU here.
And again, on Ender's screen, the scrolling and movement is all very smooth because WebEx is grabbing frames.
Yep.
And less frames that he's generating. You're seeing it jumping a little bit, but When you download the source code via his blog and the articles, you'll see the speed on your own device, machine, whatever it is.
So I'm going to pass it back to you, David.
Okay. Yeah, you have to give me the ball, and I'll just finish up real quick. I wanted to, I'm now the presenter, so I'm going to share my desktop. And I wanted to quickly just start the switch. This is a Macintosh version of Multitrack Studio, which is available. This is the Lite. It's the free edition. You can mix down 3 different tracks. And if we go over here to the Windows version, notice just the exact same. All written in Delphi. The Windows version in VCL, just because they already had it running in Windows. And the Macintosh version, there you can sort of see them side by side. Same functionality, just looking great on the Macintosh. Okay, and so with that, let me switch back to, let's see, I have to go back here and stop sharing so I can get back to the slides. So just go to multitrackstudio.com. You can download it. Windows version, 64-bit Windows built with Delphi 64, and Macintosh version built with FireMonkey. Just quickly, FireMonkey, next generation business application, great, stunning graphics, full power of the GPU. RAD Studio XE2, including Delphi C++ Builder, RAD PHP, and Embarcadero Prism, or you can buy the products individually as well. You just need one. Anders showed you the links. Here's the links again. We have all our demos in a SourceForge repository, and more demos being put up all the time. And